morning and happy Friday. I'm super excited to have another great conversation lined up for you today. So, before I get started, if you are tuning in, please feel free to drop where you're tuning in from in the comment section, as well as ask any questions during our conversation. I will try to pull you in as that's happening. I liked everybody else asking questions as well. But today I have with me Andrea from Faro. Super excited. I've been doing a lot of collaboration with them in the recent past weeks, and they just have a lot of exciting stuff going on. So, really excited to talk to one of their leaders who happens to be a woman, because that's what Mavens of Manufacturing originated from, sharing and telling the stories of women in the industry. So, Andrea, hello, how are you?
Good morning and good afternoon, depending on where you are. It's
Oh,
great
yep.
to be here today. Right?
I keep forgetting you guys are on the East Coast and I'm Central Time, but I
Well,
should.
I'm Central Time too, but we
Oh,
are global, so we talk to everybody
yes.
from all over the world.
That's awesome. Well, Andrea, I like to start off the conversations with just a brief background of who you are. So, one of the things I like to find out about my guests is how they entered into the world of engineering and manufacturing, because a lot of women have the same story of kind of falling into it by accident. It wasn't something that they pursued on purpose. So can you give us a general idea of like what your background is, how you got involved in the industry, and what you are working on right now with Farrell?
Absolutely. So I, like many women, excelled at science and math in high school. I love chemistry, and I had some hands-on experience with microscopes at an early age in high school. So chemistry, nanotechnology, microscopes, that was my thing when I got to college. So when I got to university, I went to Northwestern. I decided to major in material science. So I majored in material science and engineering and got to use a lot of really high powered microscopes. At the time, nanotechnology was the rage. And I even did undergraduate research. And then after my sophomore year, I decided I wanted to do co op. So the summer after my sophomore year, I started working at a company where I was exposed to manufacturing. I'd never heard of the company before. It's a big conglomerate based out of Chicago. And wow, were my eyes opened. No longer was it just about things that ended up in research labs and in technical papers. All of a sudden, I got to work on some really neat products that were sold at local big box stores that I could see in the grocery store. And there's a product today that honestly I use every time I put gas in my car. So it was exciting to see stuff in development and then see it in the real world.
Mhm. I think it's
So
interesting because,
following that, um,
oh, I'm sorry, I didn't mean to cut you off, and we kind of have a lag, but I just think it's interesting. Like, if you're not within this sector, you can't really connect the products that you're using to how they're made unless you're in manufacturing. So that's why I like to share stories like yours, because once you get into it, you connect the dots, and it's exciting to see how our everyday products are being manufactured. So continued. I'm sorry that I
oh yeah,
interrupted you.
yeah, I do think we're having a little bit of a technology lag. So yeah, so that was really exciting. And then as a co-op engineer, I worked as a metallurgist because I was a material scientist with a specialization in metals, and I got to do failure analysis. And that was really interesting and exciting to me because I saw how things broke. I got to go out into commercial kitchens and see rust. I got to crawl on top of refrigerated warehouses and see issues with corrosion and all sorts of things. And that was really neat and hands on. But I also saw that sometimes the reason for the failures were that failures would happen in the design of the product. And I wanted to get more involved in the upstream part of that. And that's where I think material science, which is an awesome degree and major, sometimes has its limitations because it's really often mechanical engineers and electrical and chemical engineers that do some of the really hardcore design work. And that's what got me to shift to bigger picture things. How can I get involved in new product development and still use the skill set that I had? And that's when I started looking at things like, should I become a project manager? What about new product development jobs? Um, and that's where I was also introduced to a lot of really great mentors early in my career that had their engineering degree and their MBA, and I started going down that path and thinking about it. And so after about 5 years of doing research and development, I worked for a company where I was able to just jump into, hey, I want to be a product manager, really not knowing what product management was. But they needed someone that understood metallurgy because I was a product manager for a company that made metallurgical preparation equipment. Hey, I understand metallurgy. Let me be a product manager. I just really didn't know um, what I was getting myself into. And at the same time, applied for MBA school and started getting my MBA. And those 3.5 years were some of the greatest years of my career because I was faced with business challenges. And at the same time, I was learning about business challenges. And that was a great combination to really drive home this combination of having a technical skill set. I had to be able to talk to my customer and having a business mindset of how do I grow a business and grow a product line and introduce new products that customers need.
So I think this is an interesting like connection between two ways of thinking, right? So there are a lot of engineers that are in the sector, and I spoke with another woman from the business standpoint of, but she was talking about her experience taking business classes as well, and she's like, it just helped me become a better engineer, learning the business side of things. So in your opinion, why is it so critical to start with a technical foundation, even if your heart is in strategy and business when it comes to engineering and manufacturing?
So, what I love about the technical nature is that throughout engineering school and throughout being a practicing engineer, you are solving hard problems. Getting your engineering degree is hard. Doesn't matter if you are getting C's and B's. Passing thermodynamics is hard, right?
Mm-hmm.
That degree at the end of the day means that you can solve hard problems. You know what? Business problems are hard too. If everybody could solve business challenges in the workplace, and everybody would be a millionaire, companies wouldn't fail, every new product would be a success. So the combination of having lots of different ways to go about solving a problem in your personal tool set with business skills, I think is a huge asset to come forward because you can look at things from a different way. And the other thing is that engineers make decisions based on data. I'm very analytical. If you ask my colleagues to describe me, they're going to say that I'm an analytical person. I'm data driven. It doesn't matter if that data is the output of an engineering experiment or the output of a voice of the customer survey. I look at where the data drives us to make decisions. The fun thing about being in technical business to business sales and in that industry is that I sell to engineers. Engineers are logical. They make decisions based on data, and they're making a business decision to make an investment. So they're making decisions based on whether or not the finances work out, whether or not there's a return on their investment. And for an engineer, that often means, am I going to save time by using this piece of equipment? Am I going to relieve a bottleneck by relieving this piece of equipment? Am I going to solve a problem that I couldn't solve before? All of those things at the end of the day result in a business return for our customer. And that's how we provide value. I love selling to engineers because of how logical they are. It's very different than if I were in a consumer-driven business where we were looking at things that, my decision to buy my eyeglasses or my earrings or something is very different than the decision process that I would go through to buy a ferro quantum max arm, for example.
Mm-hmm. So I have a question in regards to your personal experience as, from an engineering background and your business background. Do you think you have an advantage compared to other types of sales individuals who are in this sector that don't have that technical knowledge or background? Like how is your degree with the combination of your engineering experience and in your experience in material science really, connecting that credibility gap for you to have the right to lead innovation?
Well, I like to think that it shows that link back to the technical. Like I said before, having an engineering degree means that you can solve hard problems. And to me, I don't care. I have a degree in material science, but if it's a mechanical problem, explain to me how it works. If you can break it down so that I can understand it, I can break it down so that customers can understand it. A great example, my last organization immediately prior to Faro, I was working on test systems for automotive components. And it was not my area of expertise. It's very heavy into mechanical engineering. And I had an amazing systems engineer that I worked with where he was trying to describe what the systems do. And he finally just said, hey, do you remember free body diagrams? I'm like, yeah. And he drew free body diagrams to explain to me how we were doing the testing and spring damper systems to explain how the system worked. I'm like, I got that. That's basic. I hadn't thought about it since I was a freshman in college, but I absolutely saw the value in that. And so I think that if there are things that you can explain to me technically that will go over my head, but break it down, bring it to the basics, right? Because at the end of the day, F equals MA. You're working on a mechanical problem, right? That typically doesn't change. I know there's advanced physics and stuff, but in manufacturing world, F equals MA. Friction is friction. Let's talk about it. A dimension, a length is a length. That's where it's huge and relatable. Whereas if my background were just in marketing, and I've had classes in marketing, I don't know that I would be able to go down to that detailed technical level to relate to the customers that I'm working with.
Yeah. Traditionally, too, those departments tended to be siloed. And I just remember working in different companies where sales and engineering almost came across as rivals. Like engineers would get so frustrated with the sales team because the sales team was working with marketing and then they would like hype something up. And engineers are like, that's impossible. We cannot do that. And it was like kind of challenging them to come up with something that, seemed impossible. So there was a lot of like friction between the departments. I'm guessing like with your combination of the two, there's less friction now between the teams, and you can actually.
I think that's a unique role that like product management plays in an organization, is because the role of a product management is to understand customer needs based on the voice of the customer, to write a requirements document for a product, right? This is what the customer wants. If we develop a product that can do these things, it will drive this much revenue. Well, then of course the engineering comes back and says, well, if you want that, it's going to cost more than your target cost, and I can't do this, or I haven't developed this, or that's a technical challenge that I can't overcome. So then the product manager has to do the trade-offs. Well, if I say, okay, this is the best we can do, and I trade this off, what's that going to do to the business case, and how is that going to help us sell it, right? I have a wonderful opportunity at Faro to have a really strong team of market segment managers. And one of my guys in particular came directly as he was an account manager. So he's also an engineering background, was an engineer for a while, and got into technical sales, and now is working on my team. And he all the time says to me, when I was an account manager, I thought that would be so easy. I thought it'd be so easy to just make this change, and then I would have this product that would work. And now I see that to get an idea out the door to a successful product is actually pretty challenging. So while I might not be solving design problems, I am solving business problems every single day.
So we do have Angela Thurman tuning in from Houston. Hi, Angela. She said material science was mind-bending for me, and then she is a huge fan to project management. She's actually a really good one if you want to connect with someone. And then nothing in life is certain except death, taxes, and the second law of
I love that
dynamic. Thanks, Angela, for your comments. I really appreciate you tuning here. If anyone has questions for Andrea as we continue our conversation, please feel free to drop those in the comments. But you mentioned, the Quantum X Faro Arm series, and I want to spend some time talking about portal metrology and the future of quality control. So, what do companies most companies get wrong when selecting metrology tools, and how is Farrell helping to bridge those gaps and helping their customers really understand some of the stuff that you have going on there in your company?
So I think why I love business customers, manufacturing customers, engineers as customers is they make very logical decisions most of the time, right? But there's always the new product out there that has all of the bells and whistles and can do all of the things, or has this new feature that, oh my gosh, this is the greatest thing ever. My recommendation is to really understand your process first and then go out and research the metrology equipment that you need. Because when we say metrology or measurement or 3D measurement, rulers are used all the time. Check gauges are, all the time. Micrometers are used all the time. That's incredibly valuable. Those are incredibly valuable tools. You don't need to go up to the multi-$100,000 stationary coordinate measurement machine or CMM, right? There's a lot of gaps in between that. And Farrell plays in a particularly important sweet spot of having portable metrology, but it's handheld, it's manipulated, whether it be our handheld scanners, our laser line probes, or a portable arm, or you're using our tracker with the SMR, there's a human interaction with that. That human interaction is incredibly valuable when you can bring that portable metrology out to the line to take a measurement. That could either be because you're checking dimensions on parts as they come off the line, you're checking the diameter of a hole, the placement of a hole, or a plane, or you're scanning a 3D representation in a point cloud with our LLP and handheld scanner to get the entire data set. Understand what you need, because there's a trade-off that goes into play between just measuring that point, measuring the length of that line or that distance, that dimension, and gathering all of the data. There's some times where you need an LLP or a handheld scanner because you want to do a full-on CAD comparison of a point cloud that we generate with our equipment to your design. You want to know where the product is deforming, or whether there's shrinkage, or the manufacturing process, the machining process isn't quite right. There's other times where you really just want to make sure that each of those holes are in the right spot, and you don't need the entire point cloud, right? So understanding where in your process it's going to play is probably the most important thing for selecting the right metrology tool. And then with every tool, there's a trade-off. Data storage, right? So a point cloud takes up a lot more data than just a report of lines or holes or something in that. But you can't go back and look at the entire part. So if you're only going to make one of these parts, or it's a replica, a car model, for example, scanning the whole preliminary prototype is really important, because maybe you're going to do a destructive test and you'll never get that part back. Flip side is maybe you're manufacturing 1,000 of those components, or your injection molding, and pieces are coming off really, really rapidly. Then you can always go get another part to measure, right? So understanding that trade-off, and those trade-offs, like when you're using the Farrell Quantum Max, points are really fast to measure. Using the LLP takes a little bit more time. The LLP doesn't require the placement of targets on your specimen. So these are the targets that keep track of where you are in 3D space when you're developing a point cloud. The handheld scanners that we have use targets. Okay? It takes time to place those targets all over your part. So what's that trade-off? Because in manufacturing, time is money. So the more time that you spend doing something, the more time you're potentially wasting in your manufacturing process that you could be doing something else. Sometimes putting a part in front of the Quantum Max on our 8th axis turntable is the most efficient way to scan the part. Sometimes, because of the type of data that you need, because of the accuracy that you need, it makes sense to put targets behind the part and keep track of it in 3D space that way. Other times, you're going to put these stickers all over the part and take really accurate measurements. So understanding your process, what your data is going to be used for, and how it's going to be used down the line is probably the most important thing that a customer can understand. And then it's really easy for us to come in and recommend a metrology tool.
So where do you think quality control is headed in the next 3 to 5 years, especially with like all of the especially with like automation and AI coming into the picture? Where does quality control fit within all of that?
So I think quality control is an interesting world to work in. This is my fourth quality control company that I've worked with in my career. And quality control, by definition, is a manufacturer's pain point. Everybody that's producing anything wishes that the product or the raw material that they ordered came in the first time and was right, and they didn't have to check it. Like they got a cert, or they just trusted their supplier and they didn't have to check it. And then everybody wishes that every step of their manufacturing process worked correctly the first time, so they didn't have to do any checks at the end of the line. But we know that that's not the way the world works. So the more we can reduce the time, improve customer confidence that their parts are being made right the first time, and make it easier for them, the better. Faro plays in this world where, like I mentioned earlier, everything is handheld. You're interacting with the arm, you're scanning with the handheld scanner, or you're holding your SMR for your tracker. How can we take the errors out of that? Automation is one way to do it, but there's a trade-off between automation where you're programming a CMM versus an individual doing the scanning, because programming the scanning takes time versus doing the scanning. Now, if we can figure out a way to make it so that that human interaction is flawless and error proof, that's the best thing that we can do for our customers. So I'm thinking in terms of, I don't know, VR glasses, or intelligent, like, last time you scanned these three things, now I'm going to come up with a computer program that says scan these three things next, right? Did you check that? Those types of things. Ways that we can help take the error out of the human interaction. Because in our niche, which I think of as being relatively low volume, high variety manufacturing, which is pretty common and growing due to the customization requests from customers, we're going to be playing in that space for a long time. So how can we prevent errors and detect potential product quality issues early in our systems?
I really like the VR things that are coming out. I just spoke with someone for a CNC machining article that I'm doing for an organization that I contribute to. And one of the things that they were talking about is simulation, and why that's important within CNC machining, because if you have an error somewhere along the tool path, and you like hit something, it can damage your spindle, and those things are not cheap at all. And I just feel like with this type of portability and a measuring system for quality control, like you made a good point, it's going to really help decrease some of that human error thing. Do you see anything among, because AI is everywhere, right? And do you see that playing a role in any of the things that you're doing with portable measurement or metrology? Like, how are you guys working with that, if at all?
So we don't currently have any products on the market, but we definitely do have engineers and research teams investigating things and looking for how we can implement that, and that's throughout all of Faro's products, not just in the manufacturing phase.
It's really fascinating. We do have Mark on here. He was laughing at Angela's comment with the thermodynamics, and then Angela said something about my manufacturing career started in a semiconductor, silicon, and germanium lab. I was always amazed at how the small variation in the wow, these words I did not drink enough coffee for. Dopant material made such a difference in resulting characteristics of the material. I need more coffee if you guys want me to start talking about science words. But yeah, I wanted to talk to you because when we initially had a conversation to kind of set up this conversation, one of the things you mentioned was sort of like falling out of love with engineering. And then you were talking about your journey on how you made your way back. So can you just kind of go over that a little bit more? Because I feel like, some people who join this sector link up with the wrong companies, and like they get involved in like the wrong cultural environments, and we end up losing a lot of people, and retention is a huge problem within the industry. So do you have any advice for anyone who's coming into this space, or like anyone who's thinking about a career change? Like, what's your advice on doing the things you love, not necessarily designing?
Yeah. So I do love and will always love material science. And I do know a little bit about what Angela's talking about. However, it's been a while since I've been in that level of, of chemistry. However, um, just because your title's not engineer doesn't mean you're not doing technical stuff. My advice to anybody is to try a lot of different things and see where it fits the most. Culture does make a huge difference as far as what your first career can be like and where you fit. And that transition, at least for me, from um, college to permanent, to a permanent job was challenging. What I would encourage people to do is try a lot of different things. If you can get a job that provides breadth and less repetition, spend 6 months in one field, 6 months in another. Things that I've done over time, I've done failure analysis. I worked on new product design projects. I worked on business development projects. Lots of voice of the customer research and market research. I've done project management. As a product manager, there was a point where we lost our quality manager and I had a major quality problem. So I ventured into the world of actually being the quality engineer and doing the troubleshooting on a product. All of those things teach you and build your skill set along the way and make you a stronger, more rounded, more developed person. So my recommendation is, if you don't like where you're at, to try something new. I encourage people to reach out to mentors and relationships. Depending on where you are in your company, you might not like that specific group or department that you're in, or you might not understand the bigger picture. Sometimes mentorships, having and building your network with people in other departments or through organizations like the Society of Women Engineers, or online, networks and mentorship programs, you can learn so much more about where it fits. Because just because the first thing doesn't fit you doesn't mean that engineering isn't right for you, or there's not a very fun, challenging, and technical career path for you where you can be incredibly successful in the manufacturing world.
Do you have any advice for companies? So, like, you've worked in several different companies. Is there anything that stands out from those companies that you've worked with where they excelled in supporting their employees and then climbing up the ladder? Because I know that seems to be a big challenge, especially for like women in this space. I don't know if you've heard of like the broken rung theory, but like if women miss that first chance of promotion and moving up the ladder, it's really hard for them to get to maybe the next level of their career. And that's why sometimes they leave the companies that they belong to, because they feel like there's no room for growth or learning new things. So at the companies you worked with, was there something specific that stood out to you that really helped you in your journey and climbing up that ladder to do the things that you're doing now?
Yeah. So I guess my advice to people are have confidence, but own your mistakes. One of the greatest pieces of advice that I was ever given about individual performance is that you get data points from your peers, from your boss, from other people that you work with about your own individual performance. Think about it analytically. There's average and then there's outliers. Remove the outliers. That feedback, ignore that. That's probably not valid. But if on average people are saying, hey, this is a characteristic of how you work where you need to evolve, adapt, in order to fit in more, listen to those points, right? The other thing I would say is, don't wait for opportunities to come to you. Don't wait for your supervisor to give you an opportunity. Look for opportunities for yourself. I have been successful in switching to different roles in different companies. In the companies that I have worked for, most of them, I have had more than one position in that company. And that's been through building networks, looking at looking for job opportunities, and really saying, hey, have you thought about me? Or proactively speaking to my boss a year before I would get a career opportunity. Hey, this is what I'm looking for. This is what my development is. Because you are your own best advocate. So have confidence, own your own mistakes, be willing to continuously learn and evolve. And that change is constant. And I find a lot of meaning in the career journey and not just getting to the end game.
I love that. Is there anything that you wished you knew earlier about manufacturing careers?
Um, so what I think is awesome and both surprising to me is how big of a world is out there that I didn't know about when I was in college. And it wasn't until I took that like first step in industry, or one of my first co-op experiences was going to the Society of Plastics Engineering show. I think it was that. It's a massive, it was all of McCormick Place in Chicago was full. And just seeing all of the technologies out there and how much is there that I had no idea about. I told Megan a story about how when I was a senior in college, I took a business for engineers class. I looked at the professor, it was William White at Northwestern University, a fabulous class. I'm sure I was shy and in the back of the room. And at the end of the class, he looked at all of us rising engineering students and said, would any of you guys go into marketing? And we're all like, no. Would any of you guys go into sales? No way. Sales? Because what if your job was to sell Boeing 747s or jet engines? You know, that's different. That's a technical sale. And all of a sudden we were like, oh, I never thought about that. Because when we think about sales, there's a stereotype. And that's not at all what engineering and what manufacturing is like. So be open and explore.
Mm-hmm. I think that's like one of the big gaps that we're missing as companies is we're not sharing enough of the why and the story. So like I mentor a robotics team in the community that I'm from. And one of the things that I really like to do is try to get them to IMTS when it's in Chicago. And they were just completely blown away at the scale of things. So like they're used to smaller versions of whatever they're learning. So like the CNC machines are only 3-axis. The robotics can fit on their desktop. The 3D printers are desktop. So then when they went to IMTS and they saw these big robotic arms lifting up cars, or like the 5-axis CNC machines, they were just like, we had no idea. Like they got so big. And then they started having conversations with all the people in the booths and learning like the types of processes that they were using to create their products, and like why these were important and what these products were doing in the real world and how they affect everybody's everyday lives. And they were able to take that information and bring it to their competition, and they got further along because of the input that they were getting. So I just think that telling these stories, the plastics show that you talked about, I went to the National Plastics Show, and that happens, I think, every 3 years. But because of COVID, the first time it came back, it was like 6 years. So it was just amazing to see these giant machines that develop plastic parts. And like, I had no idea the plastics industry was so expansive when I went to that show. So yeah, I think it's important for us to like share these stories and get behind the why of why we're doing the things that we're doing, because it really attracts the attention of people. And then they're just like, I never knew. And it's funny too, because now like anytime I get on a train in Chicago or I'm on a bus or something, I'm looking at everything in more detail, like, I wonder what company makes that part, and like how they manufacture it, and if they're using additive manufacturing. Or so yeah, it's like your brain never shuts off once you get into this
Absolutely.
sector.
I did a project in 2009 on bridge building. And every time I see a bridge under construction, I think about that project and exactly what they're doing. And it is fascinating. And I'm also very thankful for all the hard work of the people that keep us safe by building those bridges, right?
Yeah. Well, Andrea, one of the things that, I like to talk about too is, getting more women involved in engineering and manufacturing, especially the technical roles. So what would your call to action be to not just women, but also companies to really help them understand why it's important and critical to get more women involved and other people in engineering and manufacturing so that we can really solidify our future in this space?
Well, I think that our businesses and the population of the people that are in our environments where we work should really reflect the population that we serve. And our population is incredibly diverse, and that diversity drives creativity. And there's tons of studies out there that show that having a diverse population brings in people with different ideas, and those different ideas help solve problems more efficiently. I think sometimes as engineers or people hiring technical staff, it's like we want someone that can jump in and start up right away. So we almost look for the the person that like races cars in their free time or that fiddles in the shop on the weekends as a hobby. Well, that's great. Those are awesome hobbies. But what about the person who leads a cheerleading team, right?
Yeah.
Or leads or cooks and is really into cooking for from a chemistry perspective. There's a lots of other hobbies and things that we can do for fun that we've been in that where those skill sets directly translate into being successful in their career. So don't just focus on the kind of more of the stereotypical hobbies that maybe someone doing robotics, for example. Just because you weren't in robotics competition doesn't mean that you won't make a fabulous manufacturing engineer, mechanical engineer, chemical engineer, etc.
Yeah, the cooking one is a great example because I don't think how many people understand like how much chemistry is involved in making baking things like the correct way. Like it's really difficult to make the perfect chocolate chip cookie or like cheesecake if you don't understand the ingredients and how much of the ingredients you're putting into
Well,
the
right.
batter.
And I used to do a lot of like wet chemistry stuff when I was a co-op and early in my career. And that's the same thing. It's measuring, it's weighing. It's
Yeah.
just, I'm not going to drink the chemical solution, right?
Yeah.
But so all of those those skills applied or being organized. I have a huge passion for the out of doors. And when I was in college, I led on like backpacking trips. Those skill sets and like understanding how to work with like the personal dynamics of a group of six, high school or college students on a backpacking trip applies directly to the dynamics of working on a team in industry, right?
Yeah.
So look for a variety of skill sets, increase the diversity, and that will have the best outcome for your business.
I love that. Well, Andrea, we're getting close to the end here. So, is there anything that you want to shout out that you're working on? Farrell's coming out with like what can we expect to see from you and Farrell in the future?
Well, I'm really excited about our upcoming trade shows and the things that we're showing off with our handheld scanning solutions and our Quantum X ferro arm. We are also showing off our tracker solution and really how those solutions are going to increase productivity and time and make your quality control processes more effective, your reverse engineering processes easier to do, faster time to data so that our customers and the engineers that we sell to can make decisions faster.
That's really cool. Do you know what trade shows you're going to be at coming up?
I know for sure we're going to be at FabTech. I'm planning on going to FabTech for sure, so I'll get to see you in person, right?
Yes. Yes, I'm super excited.
and the rest of them can be found on our website. We're global, so we're definitely all over the world. But the big one coming up in North America is FabTech.
Okay, I will definitely stop by your booth at FabTech. I'm going to be there doing some collecting of notes and data and like just seeing what stories I can find interesting so I can start reporting on those. But what was the next question I was going to I haven't had enough coffee this morning. I need to like what is the quickest way for people to get a hold of you or connect with you if they have any questions about, Faro, or even, having an opportunity as a engineer in technical sales?
Absolutely. Probably the best way to get a hold of me individually is through LinkedIn. I believe it's just linkedin.com/Andrea McMartin. Or my email address is just andrea.mcmartin@faro.com.
Awesome. Well, Andrea,
Please reach out. I'd love to meet the audience.
If you had one ask for our audience before I let you go, what would your big ask be for them?
If you're early in your career, reach out and look for mentorship. If you're later in your career, be a mentor and pay it forward.
I love
Jump
that.
at new opportunities, and don't be scared of taking risks.
I love that, Andrea. Well, thank you so much for taking time out of your busy day. I know how hectic engineering can be, and I really appreciate you spending time with me on a Friday here. To all those tuning in, thank you for your ongoing support and encouragement. Stay tuned because we got a really awesome video from Faro. And yeah, I hope you guys have a wonderful weekend. If you're going to FabTech, please connect with either myself or Andrea. Hopefully we can connect there in person. I would love to hear your story and see what you got going on. Have a great weekend, everyone. Bye.